Hello guys, in this video I'm going to inform you about how a receiver works, how a capacitor works, how a transistor works, and how a speaker produces sounds. So you might have seen various types of antennas like this wave antenna or this loop antenna or this dome shape antenna or this microstripe antenna, and there is a very common type antenna, that is a yogi type antenna. So these all antennas helps in moving the electron in a specific direction and receive or transmit this signal. Basically, this signal is a electric field vibration of molecules in the traveling media from where the signal is getting transmitted, and the transmitter may be a modem or a tower or a satellite. This signal causes oscillation of electron, or you can say to and fro motion of electrons in the atoms of the antennas. Then the positive half cycle of the signal goes through this way, and after passing through the capacitor gives a wave like this. In the negative half cycle of the signal, electron moves the opposite way, and after passing through capacitor gives a signal like this. This electrostatic capacitor can receive different range of signals according to their capacitance. Capacitor having high capacitance can receive high frequency signal, as well as capacitor having low capacitance can receive low frequency signal. The positive half travels through this wire and comes to the base plate of the transistor. By the way, this is a PNP transistor. If I say briefly, to switch on this transistor, we have to give the emitter plate a positive DC voltage and the collector plate a negative voltage. That's why the battery is attached. After all, you all know how biasing is done to switch on a transistor. Emitter base forward bias and collector base reverse bias. So after passing through the transistor, the positive half sine wave converts to a plus 5 volt square wave, whereas in the negative half there's no wave is formed and a straight 0 volt line is produced. Then the final outcome is like this in the collector plate. Then these signals passes through the transformer and comes to the speaker. These transformers are attached according to the power consumption of the speakers. Big speakers need big transformers. So speakers are basically made of a magnet and a coil. When 5 volt signal passes through the coil, it gets magnetized and causes the speaker drum to move outward, but when 0 volt signal passes through it, it demagnetizes and returns back to its normal position, and this way we can hear the message signal. I think you may have noticed that the negative half cycle of the signal is not passing through the speaker, so we are losing the signal. That's why in the position of the transistor, a audio chip like this is used. These chips contain 3 to 4 transistors and some resistors. Wait a minute, we haven't discussed the capacitors yet. So the previous diagram, the capacitor used is a non-polarized coupling type and electrostatic nature. It means it can store both positive and negative charges on its both plate when placed in a AC current. If I make myself more precise, then when AC current passes through it, it is charging at one plate. At the same time, it is discharging at the other plate. On the other diagram, the capacitor used is a polarized decoupling type and electrolytic in nature. It means it can store only the positive charge on its positive plate and negative charge on its negative plate, and it cannot be used in a AC current. One more important thing about this capacitor is it can capture the distorted voltage or ripple current and filter it to this form. So when the square wave signals containing distorted high voltage, at that time this capacitor store that high voltage and get charged up, and then the filter signal came out to be like this. one more thing about this transistor is that we can increase the volume of speaker by using a potentiometer on its base plate. You can see a potentiometer containing high voltage coils. So by increasing the voltage, we can create bigger square waves, and that causes the increase in the volume. And that's all. Thank you.